Yo, what's up everybody? Last stream of the week. Let's see if we can get everything in functional order when it comes to the water so that we can finally make it nice at the beginning of next week. And right now, let's take a quick look. We have implemented a way to make the edges nicer, much nicer. Although, yeah, much nicer. And we're currently working on the normals. So what we're currently rendering here is the dot product of the normals for this plane, and we do the dot between each normal for each vertex here and the world up. And it's just so I want to find, I basically just want to highlight normal differences like these so we know where we have them and how we and then we can figure out how we can solve them basically. What's up Hercules? Top of the morning to you. And I think it's pretty apparent here, actually, yeah, that the only normals we have problems with at the moment are the ones where they only get water from one direction. And it makes sense because when we calculate the normals of the water, we do it with every connected, or using every connected neighbor that has water. And so we pretty much we recreate a plane using neighbors. But if we only have one neighbor, then we need, let's see here, like if we have 2 points, it's easy to make a plane because those 2 points together with the source point becomes a triangle, and that's a plane. But if we only have one other point than the current one, then we only have 2 points. And we don't get the correct normals. Although I wonder, we can probably do something nice here. Let's see. Oh yeah, this was the last thing I did on yesterday's stream. It's a little bit of a mess right now. All of the normal calculations going on here. But here's basically what we do. So we create a list of all the indices to the neighbors, then we loop through it, get 2 points. If both of these points are above ground level, i.e. they have water, then we do cross product between them, and then we lerp between current normal and the new one here. Although I'm not exactly sure this is what we want to do. I wonder if we if it would be better to just add all of them and then normalize it. Maybe. Yeah, so what happens for this point is that we only have one neighbor that has water, which means that there will never exist a case where this one is true and this one is true. So this will never happen. So when we get down here, this one is false, and we just return vector 3 up. I don't know about that. Because also, if you think about it, so let's say that we want to calculate the normal from this one. We don't have a plane, we just have 2 points. We get a line, and the normal of that line can pretty much be the full 360 degrees around it. We have to specify a tangent as well. Let's say that we would specify a tangent like this. I wonder if the best option would just be to take it depends on how I want this to play out. I mean, we could just, if we only have one connected neighbor, we could just duplicate the normal of that one. But I wonder if, so in this case, this and this would have the same normals. Does that make sense? Don't think so. Yo, what's up, modding Minecraft? Hope you're having a wonderful Friday. Maybe. Okay, in this case, I think we want to take this point and this point. We want to take... What the fuck? One sec. This one, yeah, it gets its water from 3 places. That's why we get the correct normal there. Yeah, that's true. Do we have a place where we only get it from 2? I don't know. This one, I think. Yeah, this and this. Do we have the correct normal there? It seems that way. Might have some issues. But then again, I wonder if it's caused by this and this. It's roughly okay. The more I look at this, the more I just want to take the normal we have here. Maybe we should try it real quick, just see what we get. But fuck, does that make sense? So this normal right here is calculated. This one is calculated using this point, and this point. So these 2 planes. If we would do the same for this one. Yeah, I think I want to do that. Let's see. We're gonna make this even uglier, and hopefully we will have time to do a cleanup phase later today. One more thing, I'm just going to check this real quick. So the calculations we do here, we do it in the water shader currently. So in the shader, which means we do it every frame. I wonder if this would be possible to do, if we would be able to do this in the, when we set up the mesh. Just so we don't have to do as many calculations in the shader each frame, but instead we only do it when the water state changes. And if we do it on the CPU as opposed to in the shader, we can also handle different terrain patches, which is extremely nice. So if neighbor has water and this one does not. Okay, so this is a nice check. This is just a check we do when we spread the water. So this we already do on the CPU. Average water amount. So here we want to take accumulated neighbor water amount plus center values. Okay, so center values is I'm gonna have to look into this later on, but I think we should be able to do it. Check for fluid overflow. So basically what we do here is it might be hard, but have to be open for it. Okay, so back to this one. Let's see what we can do about the normal. So get water point, get water point. We're gonna clean this up a bit, so I guess we can just do get water point. I think we're just gonna do this. And then we do I still want to do this? Yeah, maybe. Okay, so now it's more about if both of these exists, we have a plane. If only one of them is true and normal instantiated is false. Yeah, okay, so we do this. Normal is equal to vector 3 up. Otherwise, beautiful. So if point A, I want to double, if point A is not equal to vector 3.0, could we actually have vector 3.0? Yeah, I think we could. minus water. One more thing, yes. Like, even though, yeah, we don't have access to the other points normal here. That's what sucks. So even if we did this, but we should be able to just create it ourselves, I think. So if we get 1 point and another point, we calculate this vector. Can we just take any other vector in the xz plane, then do cross product between those two? Would that result in... Let's try it. But I'm a little bit... yeah, we probably want to do something like this. Let's see. Get water point. Recalculate mesh at and this one we can clean up as well. I don't want to do x offset and stuff like that again, so we're just gonna do int x, int y. But we need a patch. one more thing actually. Let's see here, terrain, fluid, solver, terrain, fluid, point. The fuck, we should probably just go with having the normal here. Anytime we set the value, can we calculate the normal as well? Like if we could continuously calculate the normals in the fluid solver itself, it would be extremely nice. So we spread the fluid, and for every point we visit, we adjust the normal based on whatever fluid is being spread to it. And maybe. So for instance, if research if normal of fluid can be set during fluid solver. So for instance, if we take P and we spread to neighbors, here we do this fluid spread, or actually we just do it here. So a point is going to have a normal straight up from the get-go, because that's how the mesh looks. And then we get a fluid spread here, so we get the decrease. So or like if P is supposed to spread to N, then we just interpolate between P and N's normal. And we'll do that. It might work, but I'm all over the place currently. Let's see. Let's just do it the rough way first. Terrain patch, so back to this, whatever this is. Let's see, point A is not equal to vector 3, 0, and yeah, let's do it like this. Worst case scenario, we actually have a point that is vector 3, 0. So that one will fail, but yeah, vector 3. And point B is not equal to vector 3.0. So both of them are something. Else if point A is not equal to vector 3.0, else if point B is not equal to. Yeah, it's rough, but I just want to see if the math here is correct-ish. And here we definitely want to check if normal is not instantiated, then we don't want to do something, and we want to do it here as well. And what we're gonna do is Do I want to do this? So what if we just do so we actually have, let's see, I want to do something like this, but the problem is if we do, yeah, we're gonna keep it like this. If this one is false, probably, and we haven't instantiated our normal, then we want to instantiate it, but we don't want to set. What I'm trying to do here is, if we find 2 points, i.e. we can make a triangle and calculate a normal the right way, then that will always have precedence. But if we can't do it, we're gonna have to do it in a hacky way. So if this one is false, we're gonna do these, but once we do these, we're not gonna change the flag of this one. But then I wonder if, let's see here. So we want to do a cross, we want to do it by point current minus point A in this case, and point B in this case. So the big question is, what do we want to set this one to? And I wonder if we want to set it to, I think we want to set it to new vector 3, offset b dot x point current dot y offset b dot z. Not z in this case, but y. But we also want to do point current minus this one. We basically just create a maybe this is the way. Or yo, what's up, Himanshu? What are you working on? I'm working on, I can show you soon. We're working on some water terraforming, and more specifically, this is to get the normals of the water correct. We're gonna play it soon. It's almost like, I think, like basically what we do here is, let's do it like this for now, but I think we could just the problem is that we don't want points that has water beneath the ground level to actually affect the normals. So that's why we do it in a weird way like this. But let's see. And when it's point B, we're gonna change this one to point A. We have a little bit of an error up here, so let's just change this one to this and this. Okay, let's try it, see what we have. So let's add some water. And looks kind of rough there. And actually I don't think we have, we don't have, this didn't really think, didn't really help that much. Because yes, of course. Yeah, we don't really wanna. I tried it a little bit too quick. Himashu, oh, game dev, yeah, definitely. That's what this is. I wonder if AI helps with things when things get complex when developing games. I'm sure it could. Let's see here. It's my experience that AI, the current AIs, they help more with basic things, and they have a little bit of a harder time with complexity, especially layered complexity. But in the future, maybe. Yep, exactly what Robert Pattinson says. And good morning, by the way. So yes, of course this doesn't work because we actually don't do anything with this one just yet. So we just want to do normal is equal to normal is equal to. I love by the way. Nice to hear. Me too. Yo, good morning, Derek. Hope you're having a wonderful Friday. Hope everybody's having a wonderful Friday so far. I already saw some issues here. What the fuck is this? And what's up, you Dev? The most spoken word on your stream is water for sure. Yeah, definitely. Would be nice to have like a word cloud, and then we could see, then you could see what we were working on at certain places. I guess last this April, I think the most used word would be grass. Himanshu, yeah, experience the same. If things are basic, AI works great, but it can't help when complexity rises a bit. Yeah, it was grass before. So what is happening this time around? Okay. Here we get white, here we get... Point current minus point A. point current minus a yes. Yeah, what we want to do is, what the hell, let's just do, yeah, this is why I hate comparing to 0, because we don't want it to be 0. So I guess we can do this then. Outbool almost visible water. Yeah, let's do it like this, much like we did previously. And then we do a false if visible water A and visible water B, if visible water A, visible water B, and what we want to do here is, yeah, we want to send in these as well. Visible water A, out, point B dot X and point B dot Z. Something like this, maybe. Derek.net fixing the normals. Yes, hopefully we will manage to do it today. And Robert Pattinson, it was grass before, the next will be sky. Yeah, I'm pretty sure we will get sky soon. I don't know if it's the next one. Himashu, I'm contributing to an open source startup. It's being shedding inside VS Code, but it's way better than Copilot. It brings chatting inside VS Code, but it's way better than Copilot. That sounds pretty good. Better than Copilot. That's a bold statement. If it's on GitHub, just feel free to share it in that chat. Okay, what do we have here? Why? Unnecessary assignment. Yeah, I don't care. Okay, let's try this one instead. We calculate mesh data. I think, like, best case scenario, if we move this normal or these normal calculations to the actual water solver, it would be amazing. Like, just continuously, while spreading the water, also recalculating the normals. Okay, we have the same issue. I wonder why we're getting this type of makes no sense to me. Yeah, maybe. Road Patterson, why don't you make the gradient colors the same? Or it's not it. I'm not entirely sure what you are talking about. But we're currently visualizing the normals as a dot product between the normal and the world up. Yeah, Himanshu, I'm not famous for clicking random links that I don't know anything about, so seeing like github.com in the link would be way better. The sphere below, this one, are we talking about this one? It has a white spot on the top. Oh, this one. Yeah, we're just altering the normal to better highlight normal differences. So it's basically we output the dot product between world up and the normal of the point, but then we also change the we do an inverse lerp, so we do an inverse lerp to better highlight the gradient change, because if we would have it between the value -1 and 1, we wouldn't be able to see small changes like this. So we have pretty much just added a where do we have it? An inverse lerp here to better highlight. Like we take the dot between normal in world space and world up, and then we do, so this one is between -1 and 1, and we do an inverse lerp here, which means that every value below this one will be 0. Every value below this one will be 0, every value above this one will be 1, and then we will interpolate between 0 and 1 between these, and that's just to highlight small changes. But this ain't it. This result, however, doesn't make any sense to me. Yeah. How the hell is how We do exactly the same as here, but we set this point to be equal to, or we reset the height of this one to be equal to point current, so that we get a straight vector. And then we do cross. So it's basically like this. If we get down to these, we know that both of them don't have visible water. But if this one has it, we create a vector going from this point to this point. And then we create a vector going from... Should we be going the other way around? And then we create a vector between this point and whatever this point is. Wait, have I screwed? Yeah, what the fuck? Yes, okay. Get water point. If water is not above ground, we just return this one. That sucks. I think we just want to do this. Honestly, we could fix this later on, but okay, so what we want to do is visible water true. We just want to set this one to if water is bigger than ground, we set this one, and then we always return this one. Although we won't be using this value here. Okay, maybe. So the problem was this one, point B, in this case, point B was 0, 0, 0. So we didn't really get a usable vector. Okay, this looks good at least. I want to... Fuck. The fuck? And we need to do some adjustments here as well to get rid of this little point here. It's still not perfect. Munchy, the character looks fire. Appreciate it. Yeah, we actually want to put this one right about here. At this one. So we still have a tiny bit to fix when it comes to that, but that's not important right now. What's important is this damn normal. Why would this... I wonder if it's... So in this case, we take... So when we try to calculate the normal of this one, maybe we get to this point and this point. This one hasn't any water, but this one does. So we draw, or we make a vertex here, or a vector, and then we do a vector to here, and then we do the cross product between them. This vector going here, it only moves in the X and Z direction, so no difference in Y. And then we do the cross product between those two. This one is lower, and this one is the same, so we should be getting a lower. We shouldn't be getting white. Come on. now see it. We should be getting one vector that is I wonder, is this one, maybe we do have a better normal, but we also need to, but this looks like, I'm pretty sure this one is just white. But then again, let's take a look at this. Oops. This one is underwater. This point only gets its water from this point. Oh, okay, I see. No water, no water. This one has water. This one and this one already has the same height. So we pretty much, we do a cross product between a vector from these 2 points, same height, and a vector from these 2 points, the same height. So yeah, of course we get 0, 1, 0, which is the correct normal there. But then when we do the interpolation, we want to move this one, we want to adjust it so it becomes more like this normal. But we do that over on the, we do that in the shader, so we don't really have control over it here. And that's why we want to do this offset on the CPU as well, because then we can adjust the normal. So yeah. Because basically, the more this point moves towards this point, the more this normal should be tilted towards this normal. Does there exist a hack we can use in the shader to quickly and easily test if this gives the same result? I don't think we can. Okay. Unfortunate. And also, if we calculate the normals during, let's see here. But what the hell, we have the normal heights, but we don't have the distances. Okay. Or do we? Let's see. We could, let's see here. We could we do a hack like this? We have the normal of this point. We have a vector to the next point. If we can probably do a check here. If and this might work. If we only get water from one point, then we create a vector from this point to that point and rotate it around our normal 45 degrees. I don't even know if that's something we have to do, but then we have two vectors and we just do the cross product between those. And maybe, just maybe, we're good to go. So we're talking about something like average water, accumulated neighbor water. If we just have a number of neighbors with water, we want to do all of these things. We want to do that thing, and then we do if number of neighbors with water is equal to 1, then we're gonna do something here. We're gonna do normal. We have normal OS. Fuck it, do we have tangent OS as well? Yeah, but this one, I don't think we can rely on this one. Oh, that's true. Maybe it's this one screwing us. Because right now we're just setting the tangent to be equal to right. What the hell? If we take a look at our tangent, what do we actually want it to be? So the normal of this point and the tangent. We should be able to run with right for now, but so I don't think that's the culprit. But okay, let's do this. If number of neighbors with water is just 1, then we have neighbor position OS already. We have center position OS. Neighbor position, center position. So what if we do position OS, float 3 normal OS, and here we do position OS minus neighbor position OS, and then I wonder if we can do util math angle axis or are we working with radians? Yeah, we're working with times pi. Um, 0.25 times pi. Or actually, we want to go 90 degrees. And we want to rotate it around normal OS, I think. I'm quite skeptical about this one. I just want to see what kind of result we get. And then we do normal OS is equal to cross. I don't think we need to normalize it, but oh yeah. Oh yeah, we get a matrix from this one. So we want to do, we want to multiply whatever result we get here. So let's do 3x3 rot is equal to, and instead of temp here we do mul rot dir. Maybe something like this. Doesn't really do anything whatsoever. Himanshu, how long have you been doing game dev? Since 2016, I think. Oh yes. Oh, fuck me. Over and over I keep doing the same assumption that is wrong. And that assumption is that we actually have a difference in height between this point and this one, but we don't. Like when we try to spread to something that is higher, we just spread whatever amount we have here without lowering or heightening it. So this one still has the same height. Oh. Yeah, we don't have enough information in the shader to solve it in the shader. Yo, what's up, Cypher? Long time no see. Hope you had a wonderful summer, man. And yeah, the pairs are still 10 kilograms at least. Yeah, we simply don't have enough information to do anything about this in the shader, that is. Yeah, been busy, boy. Yeah, I assumed you to be, given the news you gave last time you were visiting, I think. I'm doing pretty good, but it still feels like I'm still in the startup phase after the summer, you know, even though I shouldn't. Like, this is the second week, I think. Or is it? Yeah, it is. Or is it? Yeah, it is. But yeah, this water terraforming stuff has almost, I mean, it has been extremely fun, but it has also been very frustrating. I feel like a broken man. Okay, so the only option we have here is to... I hate this. Can I make it so that we get the correct information within the shader? But one sec. Yeah, exactly, Cypher. Had a baby, moving house next week. Yeah, that's a very active life. So I especially appreciate you taking the time to drop in and say hello. Nah, I don't know. I don't know. Yeah, we don't have enough information in the shader. And I won't be able to feed it in an easy way. So, gotta take a step back, rethink stuff. But then again, what am I talking about? We should... we might have enough information in the shader actually, but it's just a question of how we want to handle it. If we take... Ooh, okay. Listen to this. We take the water amount here, we take the water amount here, or basically we do a vector from this point to this point, and then we have the vector from this point to this point, so we have zoop, zoop, and then we do a cross product. Could that be it? I don't even think we need to do a cross product. We can just take at the distance. Let's try it real quick. So this one and this one. They don't have any water, however, but don't we do something with that? Or 1 sec. Yeah, the hard part is that this one doesn't have water, this one doesn't have water. So how should we be able to differentiate them between this one, for instance, and this one? Yeah, we just take the opposite of this one. Okay, let's try this then. Not here, but here. So I think we can do float 3 A is equal to float 3 priority neighbor values. We don't care about this one. A is equal to this one, and we do center position. Okay, so this one, we always know that it's either plus x plus z or minus x minus z. So one of these two. So if we just flip one of them, we get this one, and then if we flip the other one, we get this one. So for one of these, we do minus here. And then of course we want to get the correct water values, so we do... It's the water we want, I think. Neighbor water max, yes, we need to do negative here as well, so -1. And it's the water value, so dot y. And then we do the same with a point B, but we do plus here, minus here, plus here, minus here. Okay, so the fact is we are at this point. We have noticed that it only gets water from one point, this one. We have saved its index in this one, and then we do add one in one direction, get this point. Then we add one in the other direction and get this point, or revert them basically. So now we have these 2 points and we have the water value as well. Then we should be able to do a vector between them and cross product with this one. Fuck, if this doesn't work, it should work, shouldn't it? So we do normal OS is equal to cross between A minus B and position OS minus, maybe we want to do center position OS, but yeah, neighbor position OS. Fuck. So what is wrong? I don't get it. We recreate this one. Let's see here, we have it here. We recreate this one to this one. And then we take this one and do cross product. It's quite a... So this one should pretty much just be a straight one, but this one we have some form of yes, okay, thank you. We need to fix this one as well. Ah, are we getting... But it still doesn't fix this one, which I'm very much surprised by. Neighbor has water and center values x is bigger than or equal to center values y. Should be okay. Number of neighbors with water. Okay, why? Oh, number of neighbors with water. We don't accumulate. This one here, why don't we? Ah, we do. Okay. So if water is bigger than ground and I is equal to J, then we do all of this, and if I is equal to J, that means that we're either at, we could actually be at -1, 0, 0, 1, 1. The 0, 0, however, won't, we only use these values after this check, so 0, 0 is okay. Neighbor has water, so this, we check for diagonal neighbors that has water here, and if so, we set all of these. Number of neighbors with water, yes. Okay, so this one, if I is not equal to -J, but if this one is true, we never entered this one. And what weird check is this? Oh, yeah, because we don't want to do it with, okay, that's true. But then again, yeah, in this case, we don't want to do it for parallel, or do we? I wonder if it would be better to do I'm very interested in what happens if we do this. And then we also do way better result when doing this. Okay, so what the hell is happening here? So for this one, okay, basically we just care about this, and this neighbor. That's what we make sure here. But what I want to do here is I also want to include, so right now we don't include this one, which sucks. So I wonder if we want to do a if instead. Do we get a difference? Yeah, we do. But if we do it like this, else if or I is equal to 0. Can we do it like this then? And then okay, this one seems to give the best result, no way around it, but we still don't get the correct normals, and that's because number of neighbors with water okay, if this one fails, then we jump to this one. So in this one we just do, we get this point and this point. No. Oh yeah, we do. This point and this point. So number of neighbors with water. If this one is 0, yeah, so if this one is 0, I think that's when we want to do this. Does that make sense? Yeah, almost. almost. Minus, plus, minus, plus, plus, minus, plus, minus. We're getting a very long here, and we're getting a short here. It shouldn't really matter, right? Oh, come on. Cross product between this and this. Or could we just do... if we just do it from a... it's this point. It's the normal for this point we calculate. We take this one. Yeah, I don't think we want to do accumulated neighbor water amount here either. We want to do... I think we want to interpolate between these two, but whatever. Because we want to take the difference between this one and this one, take the middle point of it. Or do we? Yeah, I think so. But one sec, that's basically what we do. Shouldn't really matter if we do. Normalize it, no. Yeah, I don't know why this one doesn't work. Normal OS, we set it here. Could it be tangent? No, don't think so. Or could it? Yeah, it could very well be the case that we're getting the negative normal here. This is the negative. Okay, we're very close, but not entirely there. Yo, what's up, Yuxiang Wu? What are you doing? I'm trying to get the normals for my generated water mesh to work properly at the edges. We have a tiny bit of a problem with certain points. Okay, then what if we do, and let's just do it the old way. We take this one and this one, cross product, then we take this one and this one and cross product. Ooh. Do we need to do it in a specific order? Maybe. And then we add them, then we normalize it. So A and B, normal A, cross position OS minus A, position OS minus neighbor position OS. And then we do normal B, B, and then normal OS is equal to, can we do, either like this or, oh yeah. What the hell, that's even worse. Is it because we don't normalize it? I would feel more comfortable with a lerp here as well. I don't know if the fuck. We're doing ground level here. But I don't know. I don't know if that matters. Come on. So we take, okay, depends. We take, does it work on the other side? No, it doesn't. So we take this one minus this one minus this one, and then we do a cross product. Then we take this one minus this one, and this one minus this one, and do a cross product. Do we have a problem with... Do we have a problem with the order? I don't think so. I want to see what happens if we take normal A here. And if we take normal B, Whoa. Am I missing? Maybe. Do I take these points by mistake? Could that? Neighbor water max index. No, we shouldn't. I don't think so. Neighbor has water. Yeah, we take, so this one is the index of this one. And we do neighbor water index X with a minus on one of them. So if we split one of them, do we get to... So let's say that this is minus 1, so then it becomes 1 minus 1, so then we get over here. Yeah, that's wrong. Yeah, what the fuck, we just want to do... We want to set one to 0 or the other one to 0. That's it, right? Yeah, it should be. So we switch it back to this. Neighbor water index. So it's supposed to be more like... So for this one, let's say for instance that we set x to 0. Then we want to do this, and let's say that we set z to 0. Then we want to do this, or have I lost it? Oh, we definitely want to get rid of this one here as well. This is the index we have. In this case it's -1, -1. And if we want to get this point, it's -1, 0. Yeah. Okay, let me just write this for clarity. So 0, 0, 0, 0. This should be it, I think. A, B, and then we have this one, yes. are we getting normal B, position OS minus B, position OS minus C. This one should still be correct. Yes. This point minus this point minus this minus this, and then this minus this, and then we do cross product. The fuck? But then again, are we getting... So in this case, what if we did normal A minus normal B? It's better, but still not there. So the problem seems to be, we can see here that, do we actually have... Yeah, we have this point and this point. None of them get water from somewhere else except for the diagonal direction. And we can see here that this one is a little bit darker than this one, so we do get a difference, but it's still not, like, it's not dark enough if we compare to this one. Is it because of the calculations, or is it because of that we're not using the correct points? So it's this one we have. We're working with this point, and this point. What the fuck? And the reason, I guess, we get that we need to do -1. I don't think it will work on this side though. No, it doesn't. Is because first we do vertex, vertex, calculate normal, or cross product. In this case, we take this one first and this one. In the other case, we take this one first and then this one. So we get we move counterclockwise here and clockwise. Counterclockwise here and clockwise here. Or the other way around. But yes, still it's a little bit too... And here we have a big problem. I don't know what the hell. This one seems to be lighter than both this one and this one. Right. Normal A. Too dark, I think. Okay, but what if we do position OS C, position OS is the displaced one. Send to position OS. Okay, closest one yet. But is it actually... Yes, it's probably... So this one, for instance, it depends on this, this, and this. And we actually move both of these two eventually. So they change height. We don't really get the correct normal here, and we're fucked. Closest one yet, but we still don't have enough information in the shader to properly do this. Should I just commit to doing it on the CPU? I think so. But that means that we're basically gonna have to do the offset of the point on the CPU as well. Is that something I want to do? Terrain fluid point, XY, get value, set value, set value, get neighbors. Ground mesh get vertex data. Okay, we're not using position here, so we can probably get away with altering it. Yo, what's up, Red Magician? So once again, doing this and this on the CPU instead. Red Magician, what genre of game will your game be? Cozy simulation type of game. Are we able to do this? Like number of neighbors with water. This one we can increment. Accumulated neighbor water amount. This one we can do. This we can also do, but we're gonna have to check these things. Then we need to do this. So if this one doesn't succeed, that's when we want to do all the additional calculations. So we have some point that tries to spread fluid to this point but fails. Then we want to figure out what type of neighbor it is. Yeah, this is not good enough at all. Derek, just checking in. Welcome back. What's the challenge you're facing? I would say that the root of the challenge is that we don't have sufficient amount of information in the shader to fully handle this problem. Or that is what I've concluded. And I'm not entirely sure we will have it on the CPU as well. I wonder how much this displacement screws us up. Yeah, look at this. We actually have a pretty good normal here. It's a beautiful normal, but when we distort it like it's a good normal, it's a great normal, but then when we distort it, it's not dark enough, it's not tilted enough. Could you offset the normal in the opposite direction of the displacement? So if we're moving in this direction, you're saying that we could displace this normal towards this direction. Fuck, I think this one is too low as well. I would like to be able to... I want to put it higher up, that's for sure. It's going... Yeah, the displacement is not entirely correct. I want to get it higher up, but I wonder... Yeah, we do. We want to get it on this one. Oof. One sec. Average water amount. We do it on average water amount right now. I don't think we want to do... Average water amount is this one. Red Magician, add achievements to your game. We're a bit far from working with achievements. What the hell am I looking at here? Average water amount. Yeah, we take this one into account. I don't think we want to do that. We don't take this one into account, but we take that one into account. Let's see. Priority neighbor values. Yeah, this one just becomes equal to the height of this one. Or does it? Not really. I'm pretty sure we don't want to go as far for this one as well, at least. We're definitely going too low here. Whatever water amount we have. Ooh. Oh. Yeah, whatever water amount we have here. And whatever water amount we have here. This one doesn't have water, so... Ah, we never enter here with that one. Okay, okay, I get it, I get it. I wonder... Center values, average water, okay, center values dot y, that's what we want to set here. I wonder if we want to do something like... instead. I think it works better for this one, definitely. But... Or no, actually it works... It works way better for these, but it works worse. It doesn't work for these. We want to get those two around. Yeah, what's up, Fabic? Hope you're having a wonderful Friday so far. Okay, the problem, previously we moved these too far, but now we move these too far. So compare the result of this one. This one has water, this one has water. This one doesn't have water, this one doesn't have water. So what if we were to do... I'm just trying stuff here. 0. If accumulated number of neighbors with water is bigger than 0, else or is this actually... Okay, now we're moving too far here. That's the problem we're having. This one moves the same. Doesn't really work out for this one, and that might be because we might also want to do definitely not. We want to divide this one by 3 as well. And this one is still better, but I'm not a big fan of this. I'm still not entirely sure. We're not moving as high up as we should here. And for this one, we're moving too high up. This one is the same, right? Roughly. Yeah, it is. But this one, I would like for it to go I want this one. I want the height of this one to align with this one. That's when we get the perfect. Like, we want to slide this. That might be the case. If average water amount is bigger than priority neighbor values, then we do this. Otherwise, okay, is it the fact that this one changes height as well that screws us over? It might very well be. Yeah, because this one relies on this one. Fuck me. We need to work with this one doesn't have water, this one doesn't have water. So when we recalculate the position and height of this one, we do it using this, this, and this. But this and this will actually move themselves, change height and stuff like that, which means, or does that does that remove or like, does that affect the end result of our result or of our calculations? I think it does. Because we assume that we want to place the vertex here in such a nice way that sorry about that, that we get no weird intersection. So we align our water mesh with this one and this one. So from some point in the middle here to this and to this. But the fact is, this one might have moved down to here, but then we should align it. Oh, fucking hell. Yeah, so then we get this point instead, fucking it up. And that is the intersection we're seeing here, I think. So we're seeing the intersection between, yeah. I mean, it's okay, but it still bothers me, and it might also affect the normals in a way I don't want it to. And it works so damn good for... Yeah, of course it works good for this case when we get more information from these points, because then we don't move these points. So this one, whatever this one works with during the calculations, that's the actual values we have in the end result. Way harder for a quad like this when we have more... Yeah, that's basically what it comes down to. We have more than one point that changes position. So we get some, like a chain event sort of thing. But then again, do it this solution. Okay, let's do it like this and then this. We change the water amount, that screws it up. If we can we do it with like keeping the water amount, or rather set the water amount to center values Y. Yeah, but of course we need to do it, or nah, do we? We want to keep the same height, we just want to move it. What? Average water amount accumulated. What happens? Priority neighbor values. Average water amount is equal to center values dot Y. Oh yeah, of course, that's when we get I don't know. One sec. Yeah, why the fuck is this one lower than this one? That shouldn't be the case. Unless... oh, that's true. If we quit it and then take a look at it, there we go, that's more like it. But yeah, then we get... I don't understand this one. Why is this one so much lower than this one? They should have the same value. I'm pretty sure. Fabix, sorry, been in in and out of the stream, but is it a problem with interpolating vertices that are already interpolated? Yeah, that's basically what it comes down to, give or take. It's like we interpolate a vertex depending on the visuals or the state of its neighbors. But there's this problem that the neighbors we depend on for calculating the new values, they themselves might get interpolated at some stage, which means that we get a corrupted result, basically. But this one here, this boggles my mind. We should be able to just interpolate it based on height. But this point right here, yes, this one should have. Okay, one sec. Okay, what if we do this? One sec. So this one, we don't spread from this one to this one, but we spread from this one to this one. But this one actually has a neighbor that has a higher value, and I want to switch this in the on the CPU, so we have that, because if this one had the same value as this one, I think the interpolation would go way smoother. So I want to do, ooh, this might be it. Let's see here. So we have this one. We can't do it in the shader, because if we change the height of this one to be as big as its biggest neighbor, but if we, let's see here, then we get this value. That's wrong. Or actually, this one gets this value. This one gets this value. Maybe that's what we want to do, because if we make that one bigger, and let's try it. So instead of doing average or whatever, we want to do max. So average water amount. Let's remove this line and do average water amount is equal to max of this and this. So here we get around, this is max, we should end up should end up here, I think. That's yeah, that's what we do. Doesn't look looks kind of good here. Doesn't look that good here. Is it because yeah, we moved that one way too much? Do we want this data in the... This is an edge point. We take all the neighbors. Maximum amount of water. We do the same here. We're gonna get that one. We don't want to change the... Okay, so if this is an edge node, we set the water to the max, then this is also an edge node. If we set the water to max, we're gonna get this one, and that's wrong. Fucking hell. Then we have this problem. But if we do... This one is definitely the best result yet, even though we have these small goddamn artifacts. I'm not really comfortable with them. But one sec. What do we actually set the water amount to? We set it to, let's see here, we set it to the average water amount. We set it to be equal to, well, let's do this, accumulated neighbor water amount. So it's only the like, if we did this on the CPU before we start interpolating, would that help? Would that help? Or if y is bigger than x. In this case, I'm not entirely sure how I want to do it in... Okay, so in this case, let's do... In this case, we want to do the average. But in this case, we want to do... We want to do... okay, maybe. Let's do... If it's bigger than 1, we do this. Otherwise, we just do average water amount is equal to center values dot y maybe. So this one shouldn't interpolate. I really thought we had it. If average water amount is priority neighbor value, yes. If it's bigger than 0, so what can we do about this one in this case? We want to interpolate it. We want to make it smaller. Than it is. Or do we? No, we want to make it bigger. Okay, so if we just do that. If this is true, we do that. Otherwise, we do. Otherwise, I want to. Yeah, this is the problem. So let me see. Okay, we have this one as well. That's true. Let's see what happens with this one. Get something like this. I'm okay with that. Or am I? Not really. This one, like this case, is the only one we have fully figured out. We don't. It pretty much becomes perfect. The problem is when we have an edge that either only gets water from one or two of its neighbors. That's when we get this weird intersect, because we can't really calculate the new. So we just put it to the water amount that is here. But what if we would. Would we screw it up too much if we did? Else average water amount is equal to. I guess we would. Priority neighbor values dot y. Then we'd probably go down to 0, I thought. No. Or? still a little perplexed over the fact that we couldn't get that. This one didn't work. Let's see. Like, I have no idea why taking the average of all neighbors didn't work. So, like, we don't really care about if they are above or under water. We just do it either way. Average water amount, redefinition. Yeah, let's go to this. Oh, one sec. Yeah, that's not really... One, two, three. Oh yeah. And if we take Yeah, it feels like it's a chain event. So if we fix this one, okay, we fix this one by moving this one down to, I don't know, about here. Yeah, about here. But when we have fixed that one, when we try and fix this one, we will have the wrong amount of values to work with on this one, which fucks us up. Even though so for this one, do this, it always works. I wonder, oh, it's so fucking close to the end result I want. So close, so close. And the only reason we couldn't do this from the get-go is because we have one specific case. Yeah, we have these cases where these results sucks. Actually, this one as well. Yes, for instance, in this one we can rely on this one, and this one, because we know that they won't alter positions. So we can do something like this. But for this one, like, we have to make sure that we only rely on neighbors that won't change position. And the only ones that will change position are the ones under the water surf or under the ground. Yeah, so points where the water is not bigger than the ground. But the question is, so in this case, we can only, the only point we can rely on here, the only point is this one and this one, but this one will change, but we will know that it changed. So what do we want to move this one to? And even though we move it, it's almost the same for this one. Yeah, okay, so the way we do things, we only get issues for points that relies on points that gets transformed. Could we, instead of relying on instead of relying on water surface here, maybe not. Could we rely on ground? No, we don't want to go. Fuck, I remember yesterday I was about to let this go. The only reason I'm back at it is because, like, it's an acceptable state. Yeah, it's acceptable. Yeah, but the only reason I'm back at it is because I want to get the normals correct, and I'm unsure if we can do that, if we still have this one lying around. problem might be that we only do interpolation in one direction. It works so damn nice for points like this. So points that only has, that doesn't rely on deformed points. It works so damn nice. Which makes me wonder when a point has been, when we haven't succeeded in spreading to a point 3 times, then we mark it as done and interpolate it like this. So then when we do these points, we actually have the interpolated points here. I don't know if that is something you want to do. So maybe. So the water amount in this one actually becomes smaller. For this one as well. So when we interpolate this one, we also want it to be smaller. Can we do it based on... But for this one, it also becomes smaller. I don't know. Yeah, we would be getting more like... I don't know if it's possible even. How do you make something with this topology align with something with this topology? What if maybe do you always want to interpolate in the direction of the most water? So this one, so this one, instead of going interpolating here, would you actually want to interpolate to here? Root. What the hell would happen for... At this point we don't do anything, so we interpolate towards here, probably get some... Or probably not. And then we have this one. I don't know. Let's see. Can I test this real quick? Priority neighbors, center values. We just set center values. Okay, we want this one to be true. We just do this. And we do, if this one is equal to this one, we don't use that one anymore. So let's just do true. But then I wonder, priority neighbor values. Probably don't want to check that one anymore, but average water amount. It's unfortunate. Is this really the best I can achieve? I'm gonna have to take the weekend to actually figure that one out. It's a little bit of a bummer because I thought we were done with this, but it screws up, sorta screws up the normal calculation. So I need to think about this before I actually proceed. Maybe not the best way to enter the weekend, but yeah, sometimes it'd be like that. Thank you so much for watching, everybody. Hopefully I will come back on Monday with a plan. Either way, I will be streaming. Have a great weekend. Peace.